Welcome to this Bugging Out Energy Q&A, where we walk you through why termite energy could one day provide enough energy for you to give a about. We know that many of you like to prematurely form very strong opinions on scientific matters with grey area, so we would like to kindly ask you to hold your horses and leave the bugging out to the termites and Bugs Bunny, one of our brand ambassadors. Termites already produce around 200 million tons of hydrogen per year in the wild, which in and of itself is indicative of the inherent production potential held by these little Based on the findings of the currently one and only termite bioreactor study, a 13.5 cubic meter or 2 by 2 by 3.5 meter box housing around 4.2 million sand termites fed on an antibiotic-infused diet can produce around 30 kilowatt hours of energy per day, which is enough to power an average American-sized house. Sand termites are natives of the Sahara Desert, and the other two currently recorded big producers are Reticulotermes virginicus and Reticulotermes flavipes, both native to North America. There are almost 3,000 termite species in existence, with only around 5 having had their hydrogen production measured. Almost 2,995 to go. We could even crossbreed or selectively breed standout species for mega hydrogen production. Hey, we did a pretty good job selectively breeding dogs and cows, didn't we? Coptotermes formistanus and Coptotermes gestroi are already crossbreeding in the wild, so maybe we can crossbreed certain species for both enhanced hydrogen production and faster reproduction rates. I mean, hey, if Donkey and Dragon could do it, so can they. We don't even need to collaborate with Jurassic World anymore. It's also important to remember that whilst termite hydrogen obviously won't be as fast and furious as thermochemical methods, all we have to do is feed them cellulosic waste, which mostly ends up in landfills or gets incinerated anyway, maintain temperatures unlikely to exceed 35 degrees Celsius, and maintain a bit of high humidity, and that's pretty much it. No complex control schemes, just letting Mother Nature do her thing and feasting on the fruits of her labor. In this way, termite hydrogen has advantages over other methods when it comes to scale, and we will look into ways to accelerate breeding. We believe that maintaining a constant humidity instead of a naturally fluctuating one could be key, and we're working hard on it. We're gonna keep things real steamy. You're probably also thinking, termites are so small and their mounds aren't spatially efficient and there's no way this could work. Well, good thing that most species don't actually produce those big ass mounds. And as for the size issue, consider this. Termites are thigmotactic, which means they need enclosed spaces, and planar structures just 4 to 5 millimeters high are enough to house them, which is great for spatial efficiency and for producing purer hydrogen. Ultimately, we can stack termite enclosures really efficiently on top of each other like a deck of cards or a stack of ultra-thin pancakes and get some real good hydrogen turnout. Although antibiotics do require energy to produce, ampicillin and tricycline have been found to increase hydrogen production in certain termite species by up to 7 times, where tetracycline is also able to minimize methane production. There may be some antibiotics which increase hydrogen production even further, or maybe some that have the same 7 times increase which are less expensive to produce, which warrants further research. Further study is required to determine whether the increase in hydrogen production outweighs the energy requirement for certain antibiotics, so yeah, we just gotta study and hold tight. A study on Reticulotermes spiratus, native to Japan and the Korean peninsula, produced a fermented wood feed that improved the survivability and the reproduction rate of the colony, whilst another study on the same fermented wood feed found that the acetic wood produced from the fermentation also had antimicrobial properties, which could improve hydrogen production similarly to the antibiotics and could be way less expensive than actual antibiotics. The fermentation pretty much just involved soaking some wood in water and yeast for a month, nothing real crazy, just chucking it in there, and further research could speed this up, so we just gotta wait and see. Having all of this said, when the data has been collected and the numbers have been crunched, we could well find that the most natural means of hydrogen production on the planet stands tall, but we can only find out if we get the wave going and other researchers around the world hop on and start riding. So kindly share this video with everybody you know. Thank you for listening and have a lovely day.